Hello and welcome to SudoKanard. We're here to solve this arrow Sudoku by German author Jonas Gleim. It was featured in the latest Sudoku Grand Prix. It was worth 64 points, which is generally the range of points where I perform best, which means that it takes me not that much time to solve this kind of puzzle. And it was the case with this one because it was mainly logic I had already encountered in other arrow Sudokus. So the principle of arrow Sudoku is that the digit in a circle is the sum of all digits along the arrow. And my sight was first drawn to this long arrow. The sum of all three digits here is at least 6, 1, 2, 3. Here it's at least 3, 1 plus 2, so that's a total of minimum 9, and it's also maximum 9. So this is 9, this is also 9, and so we're both in the maximum and minimum case. Those have to be 1 and 2, and those here have to be 1, 2, 3. Then those two digits have a minimum value of 4 plus 5, which is also the maximum, 9 here. Now the next thing I noticed, this has a maximum of 7, but here we have a minimum of 6 plus minimum 1. That's also a minimum of 7, so that has to be a 7 with 1, 2, 3 here, with a 1 here, so that this is not 1. Next we can see that the minimum value here is 3 plus 4 plus 1, which is 8. And that's also the maximum. So 3 plus 4, and this is 1, so this is not 1. And this one here tells us that the minimum value here is 2 plus 3 plus 4, that's 9. So this has to be 9 with 2, 3, and 4. Now this is 5, this is 4, this is not 4, this is 4, and this is 1. So it's going pretty well. Now 1, 2, 3 here. This, oh sorry, I was missing something. 3 and 4 here, that has to be a 2. That's the 3, that's the 2. So this has a minimum value of 4, and this is not 1, 2, or 4. That has a minimum value of 3. So this has a minimum value of 7 without being 7 or 9. So this has to be 8. Oops. This is 8, this is also 8. So minimum 3, minimum 4. We have 1 degree of freedom. This can't increase by 1 unit, so it will remain a 3. And this has to increase by 1 unit. That's a 5. This is not 3. All right, so this is some good job already. This column still needs 5 and 6. Let's do some Sudoku now. What next? 9 is nowhere here. It's not here. It can't lie on the arrow because this would have to be more than 9. So 9 is here. We have a 9 somewhere here. That's not very useful. Those 8s allow us to place an 8 in here. 8 on this column can only be here, and on this column it can only be here. Those are 6 and 7. This doesn't seem to be solvable at this point. Those are 5, 6, and 7. Here I need 2, 5, 6, and 7. This is from 6 and 7, and there are 4 options for those cells. I won't pencil mark them. This here is an interesting case, and it can be seen that only 2 options can happen, but I think it's not needed for the solve. I'm seeing those 8s, so this is 8, and that is the final 8 in the grid is here. Here we need 6 and 7. Perhaps this can be resolved. 1, 2, 3. This has a minimum of 4. This has a minimum of 1. So this has a minimum of 5. But it's not 5. It's not 9 or 8. So this is 6 or 7. So minimum of 1, minimum of 4. We could have 1 plus 5 being 6. No, that doesn't work because in this case, there would be no value for this cell. So 1 plus 5 equals 6 is not an option. It could be 2 plus 4 equals 6 and a 5 there. It could be 1 plus 6 equals 7. It could be 2 plus 5 equals 7. It could be 3 plus 4 equals 7. Well, that's not very efficient, I'm afraid. But this is never 7. There is a 7 in here, so those are not 7s. This is a 7. And the interesting point here is that 5 and 6 are nowhere here. This is a 5-6 pair. Oops. So that this is finally 7, and this has to be 1 or 2. And this column still needs 4, 5, and 6, and the 4 is somewhere here. The third digit is here from 1 to 3, and it's not a 2. And we're left with 4, 7, 9 in those cells. This is 4, 7, 9 pair here. 1, 2, 3 on this row, but 1 and 3 are here, so this is 2. This is 1, this is 6, this is 5, 6, 7, 6, 5, 6. So that's nice. And a 3 at the end of the row. 6, 7, this is resolved. That's not 1. So one of them here is a 1, and this becomes a 3. And 3 is here. Here I need 1, 3, 6, and 9. Those are not 1s, those are not 3s, those are not 9s, and those are not 6s. Here I need a 5 somewhere. Those are from 5, 6, 7. What about this? There has to be a 2 somewhere. There has to be a 4 somewhere here. That doesn't seem to be so useful. This column still needs 2, 4, 6, and 7. 2, 4, 6, 7. So this is from 2 and 6. This is from 2 and 4. This is from 2, 4, 7. And actually 6 can only be here. So there's no 6 in here. That is 6, and it resolves all of that. So that is 9, that is 7, this is 2, and this is a 1, no, not 1, 4, 9 pair. So on this here, those are from 2, 3, 5, and 7, so the smallest digits must be here, and their sum is 5. Right, those are 4 and 7, so 4 here, 7 there, 3, 4, 2, 3, 1, 2, 1, 2. That's not 2, this is 2. So 4, 5, 4, 7, this resolves very nicely. 5 and 6, 1 and 4. Here this is 1 and 2, so 1, 2, 1, 4, 9 and 4, and this is 5, and this is 9 finally. So really a smooth arrow puzzle. Perhaps 64 points was a little overvalued. I would say I'm comparing this to the 30 points, 30 point extra regions, which was much harder than that. Well, it depends on how it went for the testers, and I'm not blaming anyone. Thanks for watching this video. See you soon on SudoKanard.